Hypothesis testing. Process using sample statistics to test a claim about the value of a population parameter. To test the population parameter, you should state a pair of hypotheses, one representing the claim and the other representing its complement. The claim can either be the null hypothesis or the alternative hypothesis. Null hypothesis, HO. A statistical hypothesis that contains a statement of equality such as greater than equal to, or less than equal to. Alternative hypothesis, HA, is the complement of the null hypothesis. It contains a statement of inequality such as greater than, not equal to, or less than. This statement must be true if the null is false. Example number 1. Write the null and alternative hypothesis, identify the claim. A school administrator declares that the mean score for the school's fifth graders on an exam is more than 230. The null hypothesis and the alternative hypothesis. Our claim says mu is more than 230. That means the symbol is greater than sign representing our alternative hypothesis. Our alternative hypothesis, mu, is greater than 230, our claim. Which means our null hypothesis says that mu is less than or equal to 230. So our null is less than or equal to 230. Types of errors. No matter which hypothesis represents the claim, you'll always begin a hypothesis test assuming the null hypothesis is true. Then you will make one of two decisions. 1, to reject the null hypothesis, or 2, to fail to reject the null hypothesis. There is always a chance your decision may be wrong because you're basing your decision on a sample, not a whole population. Which brings us to our two types of errors. We have a type 1 error, occurs if the null is rejected when it's true, and a type 2 error occurs if the null is not rejected when it's false. An example, a grocery store's limit for selling expired products was 10%. An inspector reported that the amount of expired products sold was more than the limit. Write a type 1 and type 2 error. We found that our alternative hypothesis is our claim. So our null hypothesis is P less than or equal to 0.1. And our alternative hypothesis is P greater than 0.1, which is our claim. So a type 1 error would occur if the actual proportion of expired products sold is less than or equal to 0.1, but you decide to reject the null. Type 2 error occurs if the actual proportion expired products sold is greater than 0.1, but you do not reject the null. Types of hypothesis tests. The type of test depends on the region of the sample distribution that favors a rejection of the null. To identify the type of test, you look only at the alternative hypothesis. If the alternative hypothesis contains a less than inequality symbol, the hypothesis test is a left-tailed test. The alternative hypothesis, mu, is less than k, so this would be a left-tailed test. If the alternative hypothesis contains the greater than equality symbol, it is a right-tailed hypothesis test. The alternative hypothesis says mu is greater than k, so this would be a right-tailed test. When the alternative hypothesis contains the not equal to symbol, the hypothesis test is a two-tailed test. The alternative hypothesis says mu is not equal to k, so this would be a two-tailed test, each tail having an area of half p. A Soda Drinkers Society estimates that the mean consumption of soda by a person in China is more than 8 gallons per year, In a sample of 81 people, you find the mean consumption of soda is 8.8 gallons per year with a standard deviation of 3.17 gallons. At alpha equals 0.05, can you support the claim? First, you must identify the claim and write the null and alternative hypothesis. Our claim is the alternative hypothesis because it has a more than sign, so our null is mu is less than or equal to 8. And our alternative hypothesis is mu is greater than 8, which is our claim. Next, we identify if this is a one-tailed or two-tailed test. We look at the alternative hypothesis sign. Since it's the greater than sign, it's a right-tailed test. Since our sample is greater than 30 and it's a hypothesis test for the mean, we use a z-test. We will use the equation z equals x bar minus mu over s divided into square root n. Now you plug the numbers in. We have x bar equals 8.8, s equals 3.17, n equals 81, z equals, for the formula, 8.8 minus 8 over 3.17 divided into the square root of 81, which equals 2.217. Now we go to our z chart and look up 2.271. We find that the area is 0.9884. To find the p-value, you do p equals 1 minus 0.9884, which equals 0.0116. Since the p-value of 0.0116 is less than alpha, we reject the null. Our conclusion would be there is not enough evidence at alpha equals 0.05 that the mean consumption of soda for a person living in China is more than 8 gallons a year.